Welcome to part 3 of the Tidyverse video series. And in this part, I'm going to provide a final demonstration looking at some more of the graphics capabilities in the Tidyverse. We're just touching the surface here. We're going to dig a lot deeper, not just with graphics, but with cleaning up data, with merging data sets, with working with strings and characters, with dealing with the ability to get rid of loops. There's a whole lot that we're going to be able to do in the Tidyverse, but I'm going to focus first on graphics, and we're going to have one more demonstration, and then when you go to the next part, we're going to start actually learning how to work within the Tidyverse and learning more about it. Okay, so let's look for our final demonstration at housing data. And these are what the data look like. They're data for states at different dates. You can see that the dates here range from, all right, so first we have dates going here from, let's see where this starts. Looks like about, went a little bit too far, about 2001 here. Maybe they're not all in order. Yeah, okay, from about 2001 to 2010. Okay, so about 1 decade worth of information here on home values, the structure cost, the land value cost, because a home is the value of the home is typically a combination of structure and land. What percentage of the land is, I don't know if that's under structure, that might be under structure. A price index, a land price index, and then the year. Oh, look, here would have been an easier place for me to spot the years. So, and they do go earlier as well. It looks like back into the 80s, all the way up to 2010. And then what quarter it was in when this was taken, whether it was in the first, second, or third, or fourth quarter of the year. Okay, so we're going to use these housing analyses data to look at some graphs, and I'm going to start with a comparison of a basic graph and the ggplot, which is part of the Tidyverse. It's actually ggplot2. Here's a basic histogram that should look familiar with you, not bad. This shows for the entire data set the home values, and then we have the frequency. Just a real simple graph, but does the job. And here it is, looking at it in ggplot, very similar. We do notice that one of the things it did was got rid of the exponents automatically down here, so it's a lot easier to read the home values here. We have 250,000, 500,000, 750,000, and of course the further up we get, the fewer of the homes are in the data set. Let's take a look at trend plots. First, we'll do a basic data set with trend plots, and here's what it could look like. I'm comparing 2 states here. Massachusetts from 1980 through 2010 up here, and then Texas. And so homes are cheaper in Texas, less home value, but more affordable. And you can see that it used not to be that way back in the 80s, but over time, a lot more housing price increases in Massachusetts than in Texas, and a lot more fluctuation. All right, now let's look at that same thing with the ggplot2. I would suggest that's probably a little bit prettier graph. We have on here the states, the dates. Notice that the home value, interestingly enough, that is back in exponential form in order to be able to fit it in there, but we could change that, as we'll see later on. So now let's look at a scatter plot to look at the cost of a structure as a function of the land value, and I'm going to restrict it to the first quarter of 2001. So I'm going to take a subset, and then I'm going to use the Tidyverse to give me a little plot, and this is what it looks like. So here is the land value, and we're looking at the cost of the structure that's on that land as a function of value. Plots kind of scattered everywhere, no real relationship that's apparent to me. But let's rescale this using logarithms, which we often use when we have data that can range from small to very large. And so here it is in a logarithmic fashion, pretty easy for us to get done. Now it looks like it might be a little trend for the lower values, but then when you get to higher values, that trend seems to kind of disappear. Let's put in a prediction line, and what I'm going to do is put the values for this line from the good old linear model. And we're also going to plot home values in different colors as long as we're at it. Okay, so this first line here is not part of the Tidyverse. This is just regular old R in which I'm getting predicted values, but now I'm using those in a plot, and I have just two commands I'm going to use. And here's what I get with just two commands. So now we've created a linear function. Notice that we've got the structure cost looking better now. It's not in exponential notation. And I don't know if you can see it. We might want to pick some different colors to see it, but basically you have lighter blue. Here's one right up here. And then we have darker down here. And you see what those relate to the home values. The higher the home value, the lighter the color of the point. And so we've created this gradient here. So we have light points and we have dark points, and then we have in between. The dark points, of course, are going to be over here where the home value is less. And we're actually getting three variables on one graph, because we have land value here, we have structure cost here, and we have home value indicated by how dark the point is. Let's get rid of the linear assumption. That might not be the best fit. So here it is now again without the linear assumption. This is curvilinear graph modeling the relationship as I suspected. We have more of a relationship, and one that's pretty linear up to a certain amount of land value. Then once you get beyond that point, it kind of flattens out. And if you're wondering what that band is, that's a confidence interval band. So that's giving us a confidence interval for if we were to project from this data set to the larger population, where this curve is going to fall for that larger population. Let's look at the predicted structure costs for each state. So you can see that we have a lot of structure cost up here in Hawaii. Interestingly, also high land value, whereas in New York, not as high land value, but costs a lot more to get the structure on. Let's see, where's South Carolina? Right in here, okay, which pretty moderate land value and fairly low structure cost. Let's put the names and points together, but offset the names. In order to do this, we're going to have to install another package. So take a moment and install ggRepel. Okay, ggRepel. That's the GG stands for ggplot, which is, or GG Graphics rather, which is the package in the Tidyverse. GG Repel is not part of the Tidyverse, but someone writing for the Tidyverse. A lot of people have created packages that go nicely with the Tidyverse. So I've already installed it, so I'm going to load this, and then I'm going to look at what it does. What it does is it creates points, but makes sure that the name, the abbreviation, is not over the top of the point. And notice when things get too clustered together, it even makes a little line like it did up here for Idaho to connect the point so that you know which point the ID goes with. So that's cleaning it up, the graph, even more with that GG Repel. It looks like there might be some regional trends. So let's go ahead and put region in our plot. So now we have indicated regions with different styles of points. So notice what we've done with one two-dimensional graph. We have land value, we have structure cost, we have home value, and we have region. 4 variables shown on one two-dimensional graph. Pretty cool, huh? Let's look at histograms with the 2 different bin widths. So here's a histogram with 1 bin width. I'm not going to zoom that one out. You can see it down here. And here's a histogram with a different bin width. So it's real easy to specify the bin widths and get more precision on the shape of our histogram. What about if we aggregate by state? So I'm now going to use the Tidyverse to help me aggregate, and then I'm going to put this into a plot. And here it is. At this point, it's a little bit messy because there's so many states, but nonetheless, it does allow us to real quickly see Hawaii there with really high home values. And here's a real low home value for Arkansas. Let's use a different format for looking at this. So how about that? Okay, so now what we're doing is we're looking at 2 things at once. We're looking for each state, what the land value is. So where's Hawaii? That was the tall one. Here it is. And here's another tall one here. This is DC, District of Columbia. But we're doing it now by date, where darker is for earlier dates and lighter is for more recent dates. Let's change the breaks for these dates. Okay, so we were able to actually change up here how far we graphed from and where the different colors would occur. Let's make it even more clear with some different colors. And so now what we're doing is going all the way from a blue to a red, all the way through the violet. I'm kind of zooming along here, both because I don't want to make this video too long and also because I'm just giving you a demonstration. We're going to tone it down a bit. Here's another package written for the Tidyverse called Scales. So you'll need to stop and install Scales if you haven't done so already. And once you have it installed, let's take a look. So this gives us an even more variety of colors for our graphs. And we can also, with Scales, we can interpolate between the dates by producing a gradient. And so that's what we're going to do here. So here's this complete gradient rather than distinct colors. And so it literally is a gradient from that kind of purplish blue all the way up to the red. In ggplot2, faceting means that we're looking at small multiples. So let's try it. First, let's look at prices for various states. And so this will allow us to look at prices for various states. This one's kind of messy. This is kind of hard to read when we try to look at the trends. So let's do it by faceting. That wasn't faceting. Now let's facet to show you what that looks like. Takes a little bit of time to think through this. Here it is. And so that basically gives us a picture by state for all the states. Notice we're using the same scale on the vertical axis here for each of those states. If we want to get a consistent look, we can use a built-in theme. So here I'm using a different theme to get a little bit different look. Let's see what that looks like. Here it is. And if you don't like that, if you say, hey, I want a lighter theme, we can do that. Here's one where I'm going to take a theme that's built in, but I decided I don't like their colors. I want to use turquoise instead of what they used. Not a very good choice. It's hard to read, but there's turquoise for the date and home value. And if we want, we can even create a brand new theme. So here I am in lines 187 through 193 creating a brand new theme and then applying it. And there it is. Let's aggregate across all the states and take a look. Note that this is using a transformation in the Tidyverse. So I'm going to aggregate with Tidyverse commands, Tidyverse functions, and then I'm going to create a plot. And so what we've done in just 3 commands is we've combined the data from all the states for land value and home value and created a plot to show respectively over time how the land value has changed and how the home value has correspondingly changed. And we can see that home value stays above land value, but that they track in a very similar pattern. And that ends the demonstration. I hope you've enjoyed it. I went a little bit longer in this video so that we could finish up the demos in this video, and join me in the next part, and we will start actually learning how to do this ourselves. I'll see you then.